Okay, so we're picking back up with slide number 20 after watching our 3 videos. So if you're at home, make sure that you watch those 3 videos and then come back and pick up with us on slide 20. So we're gonna now kind of start talking about balanced and unbalanced forces. So obviously balance are gonna be opposite and equal, acting on the same object that result in no change of the object. So if the object's moving, it can actually continue moving, it's just not gonna accelerate, it's not gonna change, it's gonna be like at cruise control. All right, and so that's probably the hardest part. If you talk about balanced forces, people think, oh, it can't be moving. If it's already moving, it can continue moving on cruise control kind of indefinitely until a change is made on that object. Unbalanced forces obviously kind of makes sense as well. It's 2 or more forces of unequal strength that are acting on the same object. And this does usually result in the change of motion. So whether it's a slowing down or a speeding up or changing directions, it's basically changing the object's acceleration. And that was the definition of acceleration: speeding up, slowing down, or changing direction. So balanced forces, you get no change in motion. Unbalanced, you do get a change. Okay. Again, the hardest part with this, with the balanced, is understanding it can still have motion. If it was already moving, it's going to continue moving at the same rate and direction. I think that you have, like, you just fill in, yeah, you're just filling in, you know, these little, in those little boxes right here. So obviously you see the purple and the blue sweatshirt, they're both pushing to the left, right? And so these 2 forces are going to combine to form this thing we call a net force, which is the total force. And so if they're pushing in the same direction or applying the force in the same direction, you get to combine them. Here they're working against each other. You can see that with this vector, he's pushing with a greater force than she is. Those are going to basically subtract, and you end up with a net force that's in the direction of the greater force. And so we call that unbalanced forces in opposite directions. Here we have balanced forces in opposite directions. The red sweatshirt is pushing against the girl with the purple sweatshirt at the same amount of force, causing no change. So these are balanced because they're working in opposite directions, but they have equal strength. Okay. And I think that, again, these are pretty common sense. Like this is logical. You realize if you and somebody else combine your force, you're going to have a greater force than you had alone. If you're pushing against each other, the greater force is going to win, and it's going to end up in the direction of that force. Here, equal forces, kind of butting heads, pushing in opposite directions, you're not going to get a change. They cancel each other out, basically. Right? And so net forces are basically a combination of all the forces. Years ago, someone said, okay, so is Netflix called Netflix because it's like the sum of all videos that are all like shows and movies and, you know, everything in one location? I was like, oh, I don't know, like that would make sense, right? Yeah, right? And I had the same reaction. I was like, wow, I never thought of it like that. But Netflix, it very well could be named, and that was before, like, this was a while ago. This was before there was Hulu and, you know, Paramount and Peacock and everything, like, where you have all these streaming services. Right, Netflix was pretty much the only streaming service like that. So, possibly. I also think of, like, taking, like, a fishing net. If you take a fishing net and throw it over the object that you're talking about, and you haul it in, it's like all the forces that are involved with that particular object. Yes?
But before you had Netflix, you had cable TV, and before that you had antennas which catch certain frequencies and waves and turns them into something to display. Turns waves and sounds to analog signals. There's a science behind it.
There is a science. I'm going to hold you there because we're going to get too off topic, but you are right. You're very right.
Paper clips can even be used.
They can help boost the signal, can't they? Okay, so if we look at our vector arrows, here we see the direction obviously to the right, this one's to the left. You take the arrows and that's kind of giving you the magnitude or the strength. So if you take this arrow and remove it from this arrow, what you're left with is your net force. So basically it's like taking this, because they're going in opposite directions, you can even like physically be like, okay, this subtracted from this leaves me with an arrow like this, and that's what that's kind of showing. So the arrows are meant to be proportional or representative of the strength, okay? All right, so balanced forces. When the net force is 0, so when the overall forces on everything are 0, we get no change in movement. If we have unbalanced forces, then we have a net force that is not 0, and we will get a change in movement. So again, it doesn't say no movement, it says no change if it's balanced. No change. Obviously, unbalanced means not balanced, which means you would see a difference in a change in that movement. I'm going to come back, I'm going to get these linked in Google Classroom. We'll come back to these tomorrow. But there's a lot of sites that have a bunch of really cool ways that you can practice this stuff. Or if you just like it, you can take a look at it. Here's that static word again. Static meaning not changing. Static equilibrium is where you have balanced forces, meaning they're not changing. They're not different from or making any difference in their motion. So if they're not moving, they're going to stay not moving. If they're moving, they're going to stay at that cruise control speed and have no acceleration. They're going to just stay nice and steady. And we call that a static equilibrium. If this is a static situation where we have something not moving, not changing, if there's 5 kilograms total on this side, how many would have to be balancing it over here to keep this little pulley from moving? Yeah, we'd have to have 5, right? These are going in the same direction, so we combine them, and then we'd have to balance that with 5 kilograms on the other side. All right, so unbalanced forces in the same direction. So forces that act in the same direction, we get to add them. We combine those forces, and that causes the velocity to change, which we know means it's really an acceleration happening. So he's pulling with a force to the right. Obviously, friction at the point of the wheels is working opposite that to the left. And so we also know that gravity's pulling downward. And we know that the normal force, where it's a solid to a solid and there's contact, is going to work against gravity. So if you take this and put them together, their 2 upward forces combine to cancel out gravity's single arrow, that green arrow pulling down. So we're going to look at forces both vertically and horizontally, but for this year, we're going to only look at change in one direction at a time. So these 2 combine to cancel out the green. These 2 don't totally cancel out. You're left with a net force now of this arrow. So this friction would be removed from the force that's being applied, and you end up with the net force, or what's left over. We're not going to be left over with a vertical force and a horizontal at the same time. So either they'll all cancel out and you have a net force of 0, or you can look vertically, and if those cancel out, then you might get a net force that's horizontal, or vice versa. Maybe the horizontal will cancel out, and then you get left with a vertical net force. But you're not going to have a vertical and a horizontal net force this year. That gets a little bit more confusing. That's kind of looking 2-dimensionally, and that gets more complex. So we're going to just look at it kind of simply as a good introduction to physics. And then you might get into that more later with Ms. Durchie in the next couple years. Okay, so unbalanced forces, but opposite directions now. So before they were going in the same direction, so they combine. Now they're going to be going in opposite directions. You subtract them. All right, so if we have drag, which is an air resistance, which is a friction we know will always work in the opposite direction. So if we have 100 newtons to the right, another name for applied force is thrust, if you're talking like with engines and motors. So the applied force is 120 newtons to the left. So the difference is going to be 20 newtons, and you go with the direction that's stronger. So 120 is bigger, so it makes it left. Remember, these are vectors, so if you're writing these out, you have to include left, down, up, right, north, south, east, west. You have to include that. So 20 newtons to the left, and so the car is going to be accelerating to the left, is what that really means. Okay, so 20 newtons to the left. Okay, and so when forces are in opposite directions, the key is that you subtract them. That's the easiest thing to remember. Same direction, you add them, you combine. If they're working in opposite directions, you subtract. And I think that's a pretty basic idea. We talked about this last year as well. So movement's going to occur in the direction of the strongest force. And balanced forces mean constant, unchanging motion. It doesn't say no motion. It is constant and unchanging. So if it's going at 150 miles per hour, it's going to stay going 150 miles per hour, right? If it's going 0 miles per hour, it will stay 0 miles per hour. So it doesn't matter what the speed is, it's going to stay whatever it is. Unbalanced forces mean you get a change, which also means acceleration. Okay. And yeah, let's stop there. 27.